Okay, in this video what I'm going to do is to solve a problem that you do not really see it a lot, but you should be very careful about that. So in some types of networks, for example ISPs, you do not really see multiple area configured. But here in my enterprise network, I might have multiple areas because of a lot of different factors that we want to have. For example, isolating part of the network is going to be one of the reasons. Or let's say that having some low-end routers but still wanting to use them is going to be another one. Or overloading the routers with a lot of links, that would be another valid reason to create multiple areas. But whatever you create, most of the time what you need to do is to make sure that they are connected to backbone area. Now backbone areas do not have so many routers, and backbone areas for sure does not have does not have any servers or switches connected to them. Backbone area is going to be backbone when you have multiple areas in your network. But if you want to go with a solution in which backbone area is going to be the main area, and area 1, 2, 3, 4 and other areas are going to be created just out of mitigating some problems, then in that case area 0 is going to be a big area. And you do not really care how many routers you put in that area. What is important is the size of the database. And that is why I say when you have links like this, point-to-point links like this, you should be very careful. You should just make sure that these interfaces are configured as point-to-point so that you do not really overload the database. In that case, you can even increase the number of routers in your area. Now, the number of links are important. Like I said, for example, in this case, you can see that my router 1 and router 2, each one has 5 different links plus the loopback interface, which is going to be 6. Now, you might have, let's say, tens or hundreds of sub-interfaces in one of the routers. Then the number of links are going to increase exponentially. And that means that the size of the database is going to increase exponentially on all of these routers. And another problem with OSPF, not a problem as a matter of fact, let's say another disadvantage as a matter of fact. So another disadvantage of OSPF is because OSPF has to keep information about all the routers in the same area. This means that area growing is going to be a little problematic if you do not have enough resources on your devices. So one of the solutions would be to separate some of the routers inside another area, just putting those low-end routers in a near area. That would solve the problem. And you saw that having a sub configuration is going to decrease the size of the database very much. As a matter of fact, only one default route, but the situation should be present. For example, area 2 is a very good candidate for being configured as a sub. Now I have configured area 4 here, and for some reasons I have no direct connection to area backbone. So what is happening is, let's say that this is a branch office. My branch office is very close to another branch office, for example, which I have configured as area 1, but it is far from area 0, and I'm not going to spend money on, let's say, an expensive MPLS link between these two. So what I'm trying to do is to just have a direct connection to another branch office. That branch office has an MPLS connection to area backbone, and I'm going to utilize that one. So that is another reason that you might have, just one reason that you might have disjointed or discontiguous areas like what I have here. Now, what are the solutions to this? So in my case, for example, router 9 has a direct connection to another router, but it doesn't have to be direct connection. Just having a connection between this ABR, which I am connected to, with another ABR, let's say this one or this one, just a connection is going to suffice for our purpose. Now we are going to do this. We are going to create something like a tunnel here. Now this tunnel could be of 2 different types. Traditionally, we used to use GRE tunnels. Now GRE tunnels could solve the problem in a very graceful and nice manner, but the problem is we need to make sure that the tunnel has a very, very high cost, so that routers do not really want to use this as transit. And this is just to create the adjacency for us, nothing more than that. Because if I just configure this tunnel as with the low cost, what is going to happen is I'm going to have a lot of flapping in my network, because these two are going to create the adjacency, and all the routes are going to be are going to be displayed in routing table, that you can see everything is via this tunnel. But we do not really want to do that. We want to use the actual interfaces. The tunnel, of course, is not something physical. What is happening is it is going to change the way that we just forward the traffic. So flapping of the interface is going to be one of the problems that we need to solve here. The other way is we can just use this as a virtual link. This is, let's say, they say this is a temporary way to fix the problem, because eventually what you need to do is to make sure that this area 4 is going to be directly connected to area 0. So this means that you need to, as a matter of fact, pay for this connection in the end. But for a temporary solution, virtual link is going to be a good idea here. Now, configuring virtual link is very easy. What you are going to do is to say virtual link is this, the destination is this, and the area that it goes through is this. So that is the configuration of virtual link. But let's examine both of them and see what the problems could be here. I have not configured router 10 and 11. I'm going to do this super fast right now. So on router 10, I'm going to go with OcNOS, and let's say en configure terminal. Host name is going to be R10, and I have an interface ETH3. IP address is going to be 10.10.109.10/24, and also interface ETH1 is going to be, let's say, 111. How about that? 111, and let's say that interface loopback is going to be configured with IP address of 10.10.10/32. Now I'm going to configure router OSPF1, and router ID is going to be 10.10.10.10, and I'm going to have this network in area 4, network this one, and I would say all of them, of course, are in area 4, but let's say that we're just going to be more specific. And fine, and the end, of course, this one is going to be in area 4. Now, if I just commit the configuration, so what we are having here is a problem that says configure loopback address as secondary. Okay, I'm going to fix this problem in a second. So I'm going to just say interface loopback, no IP addresses, but as secondary. So I'm going to just remove this no in the beginning and commit the configuration. Okay, so we have this, and if I just say do show IP OSPF neighbor, right now you can see that I am neighbor with router 9. So I would expect to receive almost every route that router 9 has. So if I just go to router 9, you can see that router 9's routing table is packed with different paths, routes here. But the same thing is not going to be true about router 10. So if I say do show IP route, I have almost nothing in my routing table. The reason is my database is not going to be filled because I'm not directly connected to area 0 here. So let's do the same thing on router 11. I'm going to just configure this quite fast. OcNOS, and en configure terminal. Host name is going to be R11. Interface ETH1 is 10.10.111.11/24, and interface loopback is 11.11.11.11/32, and that would be secondary. Did I configure this as /32? Yes, I did. So on router 11, I'm going to say router OSPF1. Router ID is going to be this. And I would say network 0000/0 in area 4. Okay, so I'm going to commit the configuration, and then I'm going to show IP OSPF neighbor, which is going to be here on router 10. I just now I am in full configuration. So if I just say do show IP route, I don't have anything in here, right? The only thing that I have is the routes that I have advertised. So if I just go to router 10, and here on router OSPF, I have advertised this. Let's go back to router 11 and see. Okay, the only thing that I'm receiving is just routes from router 10. Okay, let's go and fix this. To fix this, I'm going to use router 9, because router 9 is kind of ABR here in my case. It has an interface in area 4 in router 9. If I just see the configuration, OcNOS, did they configure this or not? Show run, begin from router. Yes, I have configured this, so that is why we saw the adjacency here. So router 9 is going to create this GRE tunnel with router 6 or the virtual link, whichever you want to configure. I'm going to use the virtual link solution here, and I'm not going to create a tunnel interface. Like I said, it has a lot of problems. So what I'm going to do is to go to router 9, and I'm going to say the virtual link goes through area 1. And again, the destinations are important. I'm going to use the loopback interfaces, because on router 9, if I just check the routing table, I have access to 6666. So there is no problem with that. I'm going to say router OSPF1, router OSPF1. I'm going to say area 1, which is a transit link. I'm going to have virtual link, which is the actual link which I'm creating. I'm going to say the destination, as it says, associated with the virtual link neighbor. It's going to be 6666. Hit enter. And I'm going to say commit. Okay, as soon as I do this, if I say do show IP interface brief, you see a new interface here, but not here. Do show interface brief. You should see, as a matter of fact, a link later, which is called VL 0 or virtual link 0. For now, I don't see it. So let's go to router 6 and do the same thing. I'm going to say router OSPF1. I'm going to say area 1. Virtual link is going to be 9999. Hit enter, and I'm going to commit this. Okay, so I have done this. I'm going to say do show IP interface brief to see if there is a virtual link here, or interface brief. So it doesn't appear here, but the virtual link should be up and running after some time. So if I check them, let me see, do show IP OSPF virtual links. It says that the virtual link is down for now. The transit is area 1. Hello, suppression enabled, and remote address is a star, which is not a good thing to see here. Hello, DO inactive, and JCC is down. Let me see if I can reach through the other side. So if I say do ping 9999, the ping goes through. If I say I'm going to source it from 6666, still we have the ping successfully done. Let's go to router 9 and see what we have here. Do show IP OSPF virtual links. Okay, so it says that the virtual link is down. So right now I have configured the virtual link between the two routers, and I have used their router ID. And that is important to understand. Although router ID is taken from a loopback interface here, but the loopback interfaces are not important. The router ID is important. So if I just go to one of the routers, for example, router 9, and say show IP OSPF, you can see that it says the router ID is 9999, although I have configured this manually, but even if you hadn't, it would be taken from the loopback interface IP address. So I have just configured this, and if I just go down here, you can see that there are some interfaces configured under area 0, which is the backbone. We are on router 9 for now, and it says that this is inactive. Number of interfaces in this area is 0 out of 1. This means that one interface is configured, but it isn't working right now. But here, for example, you can see that there are 3 interfaces, and 3 of them have been configured correctly working. 2 of them are the interfaces Ethernet 2 and 3, and one of them is going to be the loopback interface. I'm going to show it to you in a second, and there is one interface on area 4 which is active. Why is this not active? That is the problem that I have on virtualization. On real devices, I'm going to show you, of course, some of these problems that we have on a virtualization environment, and I'm going to show you the fix on real devices because I have access to real lab. As a matter of fact, this is a good thing, and I'm going to show you that this is not a problem on that. So if I just go to router 6 and do the same thing, show IP OSPF, you can see that the same output is going to appear here. You can see that there are 3 interfaces out of 4 active. One of them is going to be the virtual link that I just created. So if I just say show IP OSPF virtual link and hit enter, it says that there is a virtual link which is called vlink 0. It is down. Like I said, that's because of the virtualization environment that I'm using right now. Even G doesn't support these stuff on OcNOS images. But you can see that we have created this. The transit area is area 1, and there's some other interfaces, some other information that you can check it here. For example, I have not configured authentication. That adjacency state is down. That is because of, like I said, the environment that I'm working in. The same information, of course, could be found on router 9. The other thing that I'm going to show you is show IP OSPF interfaces brief. Hit enter. You can see that virtual link is one of the interfaces right now, and for now it says down, but that's okay. Let me just reduce the size of this, and okay, so that is now the problem of this. Maybe terminal width should be a little longer. That's okay. I'm going to do that. I guess terminal, we have terminal width, and I'm going to say 256, and then I'm going to run this command one more time, and this time we have no problem in showing the information in one link. So you can see that this is the virtual link that we have here. It is down for now, but that's okay, and because of that we have no adjacency. If I had the adjacency working, what I would see was the information, exact information that I had on other areas. For example, area 1, the exact database summaries that I have received from area 0, and summaries from area 1, and maybe from others, and also an adjacency with area 0, as if we are directly connected to area 0. Why? Because we have created a virtual link between router 9 and router 6. Router 6 is connected to area 0, which works just fine. In that case, we would be able to configure area 4 as any type of area that we wanted. For example, NSSA, or let's say, for example, stop. In my case, for example, the stop would be a good idea because area 4 is not connected to anything. So that is how you just solve the disjointed or discontiguous area 0 problem.